So your answer also will be recorded. Okay, so make it clear that you do not write anything or do not make any unnecessary noise. Okay, so Arindam sir, start please.
L21 and L23 has reported. Achha. Okay, so good afternoon, students. So we are today, our experiment is the IV characteristic of NPN type singular bias transistor input characteristic of for NPN type silicon based transistor. Okay, so as usual, you can see the circuitry in your screen. Everybody has able to see the screen? Any 2 or 3 please write yes in your chat box.
Students, do it fast. Okay,
Okay.
Sandeep Kaur has written yes, sir. Okay, fine.
Oh, thank you. So you can see here, there is the NPN transistor, the symbol of NPN transistor here. So here, the middle one B means base, and here E means emitter, C means collector. Okay, I repeat it: base, B for base, E for emitter, C for collector. And we have to take the voltage VBE. Okay, and we have to take the reading of IB, that is the current through the base, and the voltage in between base and emitter we have to record. And then we have to keeping the VCE, that is the collector emitter voltage. First we have to keep constant in 3 volt. Then we have to vary the voltage VBB, where you can see here VBB, this power supply. By this power supply we have to vary this VBB, by which we can vary the VBE. We have to plot into the diagram in x-axis. We have to plot in the graph paper in x-axis that this VBE, and in y-axis we have to plot that is the IB, the corresponding reading of IB. Okay, keeping the constant VCE. Okay, so here you are already I think many of you you are already know about the observation table. You can see the observation table here. VBB means we have to vary this VBB by keeping, okay everybody, we have to vary this VBB by 0.2 volt, okay, from 0 volt to 12 volt, and we have to keep constant VCE first 3 volt by this right hand side, which power supply is connected in between VCE. Okay, but you have to rectify one similar thing, that we have to connect 100 ohm we have to connect a 1 kilo ohm resistor here, that is we in series with the collector, and instead of 100 kilo ohm with the series of base, we have to connect 100 kilo ohm in base, it is correct, and another 1 kilo ohm resistor we have to connect in series with the C, that is the collector. Got it everybody? Then first we have to fix the voltage in between VCE. Okay, that is we have to keep VCE first 3 volt. Then we have to vary VBB uh, from 0 volt to 12 volt, keeping the difference 0.2. Okay, then we have to note down the corresponding VBE, the VBE and IB. Okay, after then we have to change the voltage of VCE in 6 volt. Then similarly we have to vary the VBB in a similar way. Then we have to take the corresponding reading in between VBE and IB and the current of IB. Okay, then after doing this, then again we have to change the voltage VCE in 9 volt. Then in similar manner we have to change the VBB, keeping the difference 0.2 from 0 volt to 12 volt. We have to take the corresponding reading of VBE and IB. Okay, then I'm going to the circuitry in Tinkercad. Okay, so you can see the corresponding circuit here. Okay, Acha. Can you see everybody? Hello?
Yeah, student, please respond in the chat box if you
Yes,
can
sir, we
see
can
it
see.
clearly.
And
Yes, sir.
any problem to understand my previous lecture?
Yeah, regarding any doubt?
Any doubt?
Please write in the chat box. And I request to everyone that please mute your mic from your side. I can see many of you have still not muted your mic. So please do that. And you write in the chat box. Yeah,
So here, okay.
nobody
So may I
nobody
proceed?
has written anything. Okay, sir, you can proceed.
Acha, acha. So now you can see here in Tinkercad. So you can tally with this circuit. Here you can see this is the NPN transistor. You can see. So as usual, if you keep the flat surface towards our or your side, then you can see the leftmost one is the collector. If you key the
Okay,
cursor
yeah,
here, this is the
sir,
collector.
please, sorry to interrupt. Srina Divedi is raising her hand. So Trina, you please write in the chat box if you have any doubt. Srina Divedi, I can see you have raised your hand, so I expect that you have some doubt. Just write in the chat box first. Is there Trivedi present? Okay, sir. No. Okay, you can proceed.
So we have keep the flat surface of the NPN transistor towards ourselves. Then we can see here the leftmost terminal is the collector. Then the middle one is base and the right one is emitter. So according to the circuitry fly, we have to connect the positive terminal of the ampere meter. Okay, which is and then the negative terminal of the ampere meter we have to connect with the 100 kilo ohm resistor. Okay, and then another terminal of the 100 kilo ohm resistor you have to connect in base. Okay, after then the emitter is to be connected with the negative terminal of the power supply, this which is called VBB. So first you have to make the series connection of the input side. Okay, okay, got it. Then we have to make the series connection of the output side. That is, first we have to connect the power supply, this power supply, this positive terminal of the power supply. We have to connect it. Uh, we have to see here. This is this is 1K and this is 100K. So you can see here, this is we have already connected here. See, this is VBB. Okay, so this is connected. This positive terminal is connected with the positive terminal of zero of the milliampere meter, which I already connected it. Okay, then the negative terminal is to be connected here. Okay, then this then this register is to be connected with the base in series. Okay, then the emitter, then the emitter terminal, then the emitter is to be connected here. Okay, then this series connection, and this series connection we have to connect with the negative terminal, that is the ground terminal of the power supply. Okay, so okay, got it. Then what we have to do, and then this is the series connection of the power supply. This is the series connection of the power supply. Okay, then we have to make the output side of the power supply. This power supply is for the output terminal. So this is to be connected. This positive terminal is to be connected with this register. Okay, and this register is to be connected in series with the collector terminal. Okay,
Okay,
and then
Rohit, Aich, you please mute your mic. Rohit, Aich, you please mute your mic, and all of you, I again request you to mute your mic because noise is coming from this side. Rohit, Aich. Okay, Anindam, you continue.
okay, thank you. Now I am repeating here again, this positive terminal, that is this positive terminal, we have to connect with this terminal of this register. Then this register we have to connect in series with the collector terminal. Okay, then the emitter is already connected with the ground terminal. Okay, and this ground terminal of this power supply is connected with this here, which is connected already here with this ground terminal of this power supply. So all the ground terminal of the power supply is to be shorted with the emitter here. You can see. Okay, so this goes your series connection. This goes your series connection. Then we have to connect the parallel connection. So 2 voltmeters, 1 voltmeter. This is the power supply. You can see we have it is not necessary to connect this voltmeter with the power supply because it is already is there. This voltmeter is there inbuilt with this power supply. Okay, then we have to connect this power supply. Okay, actually the multimeter we have to keep in the voltmeter mode. So this multimeter, which is acts as a voltmeter, this is to be connected in between base and emitter, so that we can measure the voltage between the base emitter and another this multimeter we have to already connected here whenever we connected the series connection. That is here, this positive terminal is to be connected with the positive terminal of the milliampere meter. then the negative terminal here is to be connected here with this register, and which is connected with the base. Got it, everybody? Then what we have to do? Then we have to keep this power supply in first in 3 volt, all okay, got it? Then all
उसका
these
साउंड सही में नहीं आ रहा है.
हेलो 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 हेलो
hello,
अरिंदम.
हाँ
हाँ अरिंदम.
हाँ
हेलो. 3
हाँ,
वोल्ट
please
ना
tell
करे
Modu.
दूरा. हाँ.
हाँ?
You have to just
नहीं,
set
message
this voltage VC,
इसीलिए
that is 6
करो.
volts, 6, 7, 8.
हाँ.
Okay, don't use 3 volt. Okay.
No, we have to set first in 3 volt. Okay.
No, hello.
हाँ.
3 no, it is 6 volt. 6, 7, 8 or 6, 8, 10. Okay. Don't do 3
Not
volt.
3 6, not 369.
Yes. You 6, 8 and 10. 6, 8, 10.
Okay. So Modhu sir is telling to keep the VCE 6, 8 and 10. Is it right,
Yes.
Modhuda?
Yes.
Okay. 6, 8 and 10. Okay, so we have to keep it in 6 volt. Okay, we have to keep set in 6 volt. Okay. All other parameter we have to make it in 0 volt. Okay, this is to be kept in 0. Okay, and here first all we have to keep kept in 0. Okay, in 0 volt. Initially first make the circuit. Okay, then you have to start the simulation. Okay, first you have to make the circuitry in the Tinkercad, then you have to start the simulation, then you have to vary accordingly, which I told. Okay, any problem, students? Do you have any problem or any doubt?
Mention in
No,
chat
sir.
box. Okay.
Okay, I'm mentioning.
Chat box.
If you have any doubt, please mention in the chat box, please. Okay, any problem, student?
Students, please respond in the chat box.
Please
Is it
respond.
clear?
अबे चुप है. Mute करो.
Students must write in the chat box. Your interactions are pretty much important for
Mohammed
this
Tasif,
class.
don't talk.
Okay, one of you has written no, sir, no problem. Okay, what about
Yes,
the
yes.
others? Why are you all silent?
Please
It is
respond.
important to make your presence here. All right. You write something.
Yes.
Later, if you have any problem, I will be with your chat box. Okay. I clear that out. Okay.
Okay, sir, you proceed, please.
Okay. So here you can see we have taken the 2 type of resistors. One is 1 kilo ohm and another is 100 ohm. Got it? So 1 kilo ohm is to be connected instead of here 100 kilo ohm, and 100 ohm you have to connect in between this power supply and the collector in series. Okay, got it?
Okay, yeah.
Here.
Kuntal Mohanta, Mohammad Tasif Akhtar, Shreyashi Chakraborty. You please mute your mic. There are many noises coming from your side. Kuntal Mohanta especially. Also, another 2 I have named him, Tasif Akhtar. Mute your mic. Okay, sir, you proceed, please.
So any doubt about it, then please tell in the chat box. If you have no
Okay, sir,
problem,
till now, no doubt.
no doubt.
Yes,
Okay,
no
okay.
Proceed.
So I'm Acha Shuman, can I over you?
Yes, sir. Yes, sir.
Okay,
That's
okay.
it, sir.
Then please take. Okay.
Okay.
Over to the Shuman.
Okay. Okay, so last day there is some internet connect due to some internet connection. So we just shared a copy and tell you that told you that you have to make the circuit. Many of you have submitted the circuit in your Google Classroom, but still many of you didn't. Okay, so today sir has shown you how to take the reading. So so today what you have to do, you have to first complete the previous experiment. By tomorrow you have to submit, and by next 3 days you have to complete this. You need to complete this experiment and you need to submit that. Okay, and last 10 to 15 minutes you have to appear for a uh, um, test, online test, IMCRP. Okay, a code will be shared to you. Okay, and you just go for the test. Okay, now if you have any confusion regarding how to take the readings, okay, how to plot the graph, you can ask. Otherwise we will going to adjourn for today. Is there any confusion from student end?
Students, please respond very fast. The time is running out in the chat box.
Acha,
Where to the plot?
Yeah, Shaumadeep is saying yes. Suman, you please tell.
where to plot? Okay, so
Shaumadeep
you
is
can,
telling I had submitted previous experiment.
yeah, that's okay, means
So
who has
now I
submitted,
just
there
proceed
is
to
no
this
issue.
one.
Huh?
Okay. In graph,
Okay, Arindam, the one Vishwanath Ghosh is asking, sir, where to plot the graph?
acha. You can plot the graph in Excel or in
MATLAB.
if you have or MATLAB, or
Okay.
if you can plot in the graph paper, and there by snapping you have to submit in Google Classroom. Okay, so actually you have to submit this screenshot, and one another thing, you have to write your name in this box. Okay, that is the left corner above your name. As I written, my name is Arindam Banerjee, BJT input. I have written, but you have to write your name, section, and roll number. Okay, here. Okay, do you got it, everybody?
Acha,
And
sir, another thing, sir, please show them the experiment workbook. Okay, have you downloaded that?
experiment workbook. Oh, we have to. We will submit it in their common WhatsApp group.
Okay, we will submit
Okay.
it there, and you just download the workbook, then fill it out, then fill it and then submit. Okay, no need to separately submit your all the things. Okay, in the single page you go there, in a workbook you have to go there. Okay, you have to fill the required columns. Okay, plot everything, you have to plot there and then you submit. Okay.
Okay. Okay.
Okay, Abhishek
Okay,
has one confusion. Can you tell how to take the reading?
okay, Orindam sir,
So,
you just show how to take the readings. 1 and 2 readings,
acha.
just
So,
show that.
okay. So you have to take you have to keep the VCE first, 6 volt, then 8 volt, then 10 volt. Okay, by keeping VCE 6 volt, you have to vary VBB by 0 to 12 volt, keeping the difference 0.2, that is 0.2, 0.4, and you have to take the reading of the corresponding IB and VBE. Okay,
Acha, Orindam sir,
you have to take you have to keep the difference 0.2 and vary VBB from 0 to 12 volt.
acha,
Okay,
Orindam sir,
that is 25, and including 0 volt, 25 reading will be there.
acha,
Okay,
Orindam sir,
yes, Suman, please tell.
acha, Orindam sir, please
Yes.
show them how to
Yes,
take the
yes.
readings. Means taking one readings. Okay, giving one example.
Acha, giving one example. Acha.
By varying the supply, VBB.
Yes, sir. Yes.
VBB.
Acha.
Okay.
So
Suppose this is
here,
0.2 like that.
so So first you have to
Set the
here.
voltage by VVV 0.0, 0.2.
Acha. So here,
Left side source.
okay.
Left side
So
source.
here power supply, it will be 0 volt, and the current should be set in 1, and then here this power supply, we have to
Set
keep it in
6 volt.
first 6 volt.
Yes.
6 volt. Then first stop the simulating. First stop the simulating. Zero, okay, and the current should be 1, okay, and here first set it 6, okay, then saving, then we have to start stimulate. Saving, then ওহো এটা তো আবার চলে আসছে, এটা already I have জানতে পারছি না।
Set it to, okay, the only that voltage you just vary the VVV. Okay, student can change the value. Yes.
Okay, I am unable to.
This is the example for that.
Acha.
12 volt is the set for VVV, VCC.
Acha. First, I am giving it 0.0. Okay. It is 12 volt. It is so
6 volt. Is it 6 volt?
okay.
6.
Initially, we should do this. এটা তো আনতে পারছি না। আচ্ছা।
এটা already saved. Okay.
It is saved. It is already saved.
Go to the input side.
Input side.
Vary the VVV.
No, I mean initially we have to keep it in 0 volt. Okay. Then
Yes.
we have to set for this 6. Okay. Then we have to start simulate. Oh. Okay.
It is already saved.
This is already
Don't go
saved.
there.
এটা already save করা হয়ে গেছে। So I already actually I already did this experiment and it is already set. But initially you have to keep this VCE in 6 volt. That is 6 volt, and then you have to keep all these two in zero, okay, and current 1. Then you have to vary it this VBB, that is 0, 0.2, 0.4, 0.6, 0.8, like that up to 12 volt. Okay. Okay, got it everybody?
Yes.
হ্যাঁ এটা তো আবার 12 ভোল্ট হয়ে গেছে।
Yes.
তো এটা তো এটা মানে অ্যাকচুয়াল রিডিংটাই তো
forget about that. VCC is forget about that. You just vary three reading 0, then 0.2, 0.4, and 0.6, and so the reading in VBE and I.
Okay. So keeping the 12 volt VC 12 volt, I'm showing you the VBB 0 and 0.0. Then you can see
that current should
the
be
current should be 0. Then 0.2. Then again this current is 0. Then 0.4. Then here again the current is 0. Then 0.6. Then here also 0. Then 0.8. Here the current is 85.7 microampere. Mind this VBB should be in microampere. Okay. Then 0.8. Then 1. Then 1 volt. Then VBB is 257 microampere, and VBE by this is actually the annotations. This is actually the annotation here. By this annotation, you can just drag it here, and you can write here VBB, here IB, or here VBB. All this annotation you can you can write this annotation from by dragging here. Okay, and here the corresponding VCE is 62.8. We don't need that. And by keeping VCE 12 volt, you can see here that this this what I 1 volt, that is 1.2. So VBV 1.2. You can see IB is 446 microampere. Oh, sorry, for IB is 446 microampere and VBE is 754 millivolt. Okay, or you can
You have to
write
write in volts.
0.754 volt. Okay,
Yes,
got it?
Yes. Yes.
Got
yes.
it? And any problem do you have, students?
Students, you
Students?
please respond in the chat
Please
box.
response in chat box.
Okay, I think student have
Arindam da,
understood. Okay, if you face any problem, so write down in your WhatsApp group. Okay, we will help you. Okay,
Yes.
student.
Okay.
Sir, we should
Okay.
end now. Okay.
okay, so should we adjourn?
Okay, sir. Okay, sir.
Okay, thank you,
Okay.
everybody. Thank you, students.
Thank you.
Thank you, sir.
Mhm.
Thank you, sir.